Hello everyone, my name is Lotfi, and in this video let's talk about the electron distribution and chemical properties of atoms. And these are the main subjects for this video, and so let's get started. So the chemical behavior of an atom is determined by the distribution of electrons in the atom's electron shells. Okay. And these are the electrons of beryllium, which has 4 electrons, and it has its own chemical behavior. Okay, and now we want to make virtual imagine making a virtual element or atom of an element. Okay, so we want to start with hydrogen, and as you know, hydrogen is the most simple atom that is in the world. Okay, so it has 1 proton and 1 electron only. Okay, so no neutrons. And now we want to make the next atom. Okay, so we have to add one proton and 1 electron, and of course we have to add a number of neutrons too, but the number of neutrons are not exactly going in order. Okay, for example, the number of neutrons go actually like this. Like this one. 1 and 2 and 4. Okay, as you can see, it doesn't go in order. Okay, so yeah, we can't imagine the number of neutrons which are inside every atom. Okay, so yeah, the atoms are virtual, not real. So in this picture, that is a kind of table that is called a periodic table. So it is the modified version of the periodic table, and it actually shows the distribution of electrons on the electron shells of the first 18 elements, so meaning from hydrogen, H, until the element argon or Ar. Okay, and you can see in this picture. As you can see, the elements are arranged in 3 rows or periods. Okay, which are corresponding to the number of elements, electron shells in their atoms. Okay, and so the left-right sequence of elements in each row corresponds to sequential adding of electrons or protons. Okay, and this picture is a complete version of the periodic table. Okay, so yeah, it's this picture is a modified version. Okay, so as you can see, the 1 electron of hydrogen and the 2 electrons of helium are inside the first shell. Okay, and so electrons, like other matter, tend to exist in the lowest available state of potential energy. Okay, which in an atom, the lowest available potential energy for electrons is the first shell. However, the first shell can only carry 2 electrons. Thus, hydrogen and helium are the only elements in the first row of this periodic table. Okay, so in an atom that has more electrons than 2, it has to so it has to give the other electrons that are more than 2. Okay, so it has to give the third or fourth one to the next shells, okay, or to the second shell, okay, because as I said, the first shell only has the capacity of 2 electrons, but the second shell has the capacity of 8 electrons, okay. So as you can see in this picture, we have 8 elements in the second row, okay. So for example, neon, which is the last atom or element in the second row, okay, it only has, as you can see, it has 8 electrons in the second shell, okay, electron shell, and it has 2 electrons inside the first shell, okay. So, and when you add these numbers, the neon has 10 electrons in total, okay. So let's continue. So the chemical behavior of an atom depends mostly on the number of electrons that are in the outermost shell, okay. So not this is a better way of saying what does the chemical behavior of an element depend on, okay. So not on the whole electrons, but mostly on the electrons that are in the most outer shell. So for these electrons, which are the farthest from the nucleus of that atom, okay, these electrons have, how do I say it, are named valence electrons, okay, and the shell that has these electrons inside it is called the valence shell, okay. Valence electrons, so the chemical behavior of an atom is dependent on the valence electrons, okay. So for example, in lithium there is only one valence electron, okay, and the second shell is the valence shell, okay, and you can see you can see lithium in this picture. But some atoms have the same amount of valence electrons, and so they exhibit similar chemical properties. For example, lithium and sodium, okay, Li and Na, okay, they have only one valence electrons, okay, and you can see in this picture that hydrogen, lithium, and sodium, all of them have only one valence electrons, and as I told you in the previous slide, the valence electron is the electron that is farthest from the nucleus, okay, and as you can see in this picture, the one electron that is the farthest from the nucleus in lithium is the third one, and so the one in sodium is the 11th one, okay, and the hydrogen is the first one, whatever, okay, and so these, as I said, exhibit similar chemical properties, okay. So for example, they both bind to chlorine, okay. For example, when sodium binds with chlorine, it is sodium chloride, which is the same as table salt, and when lithium binds to chlorine, it is a kind of salt, but not that kind of salt that you are thinking. You cannot eat it. It's not very good for the body, okay. And as we will learn in next videos, these two atoms, okay, lithium and sodium, and sometimes hydrogen, they have a tendency to lose their only valence electron. Okay, but don't worry, we will learn about that in next videos. So now, but some atoms, okay, or elements, are very unreactive. Okay, they don't give easily, they don't bind very easily with other elements or atoms. Okay, some of these examples are helium, neon, argon, krypton, and so on and so forth. Okay, and you can see some of them in this picture, which, as you can see, one of them is helium, neon, and argon, but we have other ones as well in the periodic table. Okay, so these elements are said to be inert, meaning that they are chemically unreactive. So all the atoms are chemically reactive because they have an incomplete valence shell. Okay, but these have a full valence shell, and they don't tend to give bonds. Okay, and they are also called noble gases because they don't need other elements, or they don't even give bonds or create bonds between them and other atoms. Okay, and so that was all for this video. I hope you enjoyed this, and this video was very helpful for you. If you liked it, you can just hit the like button and share this video to other people, that they can gain knowledge as well. Okay, and so I will see you in the next video, and happy learnings to you all.